Welcome to our 2D math course. Today is the first of many lessons that you will listen to. Unfortunately, this is the way we need to do things, but for some of you, this might actually be a really cool thing because you can go back and listen to me, my wonderful voice, over and over again if you really wish to. But in any case, we are going to go through what the types of number systems are first today. And I've set up this Venn diagram because really the number systems, one fits inside of another. And I'm going to start in the centermost circle on the top here. And we're going to talk about the very first number system you ever learned, whether you knew you were learning it or not. And that's called the natural number system. It's the one you naturally learned when you were first learning numbers, natural. So these numbers are the ones that you first learned. So they're 1, 2, 3, and so on, ... And we use a symbol to represent the word natural when we're talking about a number system, and it's the letter, capital letter N. And sometimes it's in boldface, but I have trouble doing boldface on here with my pen, so I just make that first stroke extra thick to indicate that I'm talking about the natural number system. Now, as you went on in life, you learned more about numbers, and you ate all the little Cheerios that Mom put on your tray, or Grandma, or whoever was looking after you. It could have been Dad. And you learned the concept of nothing. You had none left. So the next number system we talk about includes 1, 2, and 3, but it also includes 0. So it starts at 0 and it goes 1, 2, 3 after that, and so on, ... And this is called the whole number system. Okay, and I remember this by naturally learning the natural numbers first, and then the whole number system has the letter O in it, and it includes the number 0. Now, its letter that we use to represent the whole number system is a capital W that I've put on there. Then we learned the fact that I go shopping with Mom and I don't have enough money for this candy I would like to buy, so I have to borrow some money. And we get into negative values. So you had $0 to begin with, you buy the candy, now you owe Mom $2. So you're in the value of -2. These numbers are called integers. And if N is for natural numbers and W is for whole numbers, integers are represented by the letter Z. Don't ask me why, I really don't know, but somebody decided that. Some textbooks have morphed into using a capital letter I, but I or Z was the more traditional letter that they've used to represent integers. And I'll just put down here ... comma, -2, comma, -1, comma, negative. Oh, sorry, that's not a negative, that's just 0, comma 1, comma 2, comma ... You can keep going in either direction there. From there, we're going to add another number system because sometimes you eat half a pizza and your sister eats the other half, or your brother, and we've got what we call the rational numbers. Rational numbers, and its letter is the letter Q. That's the letter Q, and again, I just kind of boldface it with an extra line on it. Now, these ones are a little bit trickier for me to write in here because it's more of a description. A rational number is any number that you can write as a fraction. Any number, and this is the number symbol, it's not hashtag, any number that can be written as a fraction. So in terms of that, all of our whole numbers and natural numbers and integers can be written as fractions. For example, the number 4 could be written as 24 over 8. I did that wrong, that's 3. Anyway, we can do a division with it, which really a fraction is division. So all terminating decimals can end up being written as fractions as well. Oh, that's an arrow, just like a bullet or whatever, an arrow, just to indicate this is a subpoint. All terminating decimals. I apologize, I'm moving into other territory. When I wrote it in pencil, on my paper, I could fit it in, but this does not have great precision when I'm using the stylus here. So 0.25, that really is a fraction of 1/4. 25 cents is a quarter of a dollar. So 1/4 definitely is a fraction, definitely is a rational number. Along with that, any repeating decimal is a rational number. So any repeating decimal. Again, I'm in the other territory, but you get the drift here. Decimal. So any repeating decimal. So for example, a simple one would be 0.3 with a line over top of it. That line means to repeat the 3. So 0.3333333. It's a common fraction. That's really 1/3. Okay, now we also have decimals that are not terminating, not repeating, like pi, and those are called irrational. So all of the ones above in the bigger circle up above, we could write as fractions. There are some numbers in life that we can't write as fractions. Those are irrational. And we use the letter Q again, except this time there's a bar over top. It doesn't mean the Q repeats like it does with the repeating fraction. What that means is that when you see a letter with a bar over top, it means the opposite of what you have. So if you take any logic courses in university, which I did, or if you do computer programming, you're going to get into symbols with bars over top, and it means the opposite of what you're talking about. So these are your non-terminating, non-repeating decimals. Non-terminating, non-repeating, that's a comma, non-repeating decimals. Okay, so for example, pi is a non-terminating, non-repeating decimal. The square root of 11, if you put that into your calculator, it's a non-terminating, non-repeating decimal. Now collectively, if we put rational numbers with irrational numbers, those make up all the numbers we possibly can think of, and those are called the real numbers. I'm just going to switch colors because I've kind of overstep some bounds on my other circles. So anything that's in red is a real number, or has to do with my real numbers here. So it's actually sensible. It's a capital letter R that's bold-faced. So this is any number you can possibly think of. So if we combine our rational numbers with our irrational numbers, that makes up our real number system. Any number that you can think of. Now, there is another number system that we don't talk about in high school, but I'm just going to mention it briefly here. Another system called the complex number system, and it involves what we call imaginary numbers, where we use the letter I, the lowercase letter I, to represent the square root of -1, which we know on our calculator, if we try the square root of -1, we get an error. But we don't have to worry about that, but I want you to know this is not the be-all and the end-all. There is more out there, but sometimes in math we only give you part truths or part of the story, and then the next year we will clarify. But the complex number system doesn't come in until you get into potentially university, and even then it only depends what courses you're going into. Okay, from here we're going to identify the number system that each number belongs to. So if I look at the number 2, that's definitely a real number. It's a number I can think of. It's any number. It is rational, not irrational, rational, because I could make that like -2 divided by 1, or I could make it -4 divided by 2 as a fraction. So it is rational. It is also an integer. So I put a Z there. It is not a whole number, though. It's not a natural number. So I'm kind of working on my outside and then working my way in, seeing how far in I can go with my number systems. Try the next 4 that we have left here. Put me on pause, and then you can check your answer. Okay, 0 should be real. It's rational. It's integer, and it's whole. -0.5, that one should be real. And it's rational. I should switch to a different color so that you can actually see which one goes with which. We've got a repeating decimal. It's a real number. It's also rational. And I think on the last one I may have accidentally put a little bar over top of my Q, and I didn't mean to. I'm sorry about that. There we go. That's just the Q. All right, so that's a repeating decimal, but it's definitely not just an integer because I can't, it has a part amount to it. It's not a whole number. And square root of 7, that one's a non-repeating, non-terminating decimal. Change color again. This is still a real number, but this time I'm going to have my Q with a bar over top. It's irrational. Thanks for listening.